Welcome. Today we're going to talk about two different forms of linear equations. One form is y equals mx plus b, and that's called y-intercept form. You can also call it slope-intercept form, depending on what book you read for fun. The other form is ax plus by equals c, and that's called standard form. Now, probably you are a little more used to this form because we've been using that to write linear equations and graph them using the slope, which is right there, and the y-intercept. So we're going to talk today about how to put this form into y equals mx plus b so that you can more easily graph. All right, so the first problem we're going to do is x plus y equals 4. Now, if you had to graph this, you could just generate a table of different ordered pairs that add to give you 4. That might be easier. There's also an option to isolate the y here. So if you subtract x from both sides, your y-intercept form of this equation is y equals negative x plus 4. That's the same thing as y equals negative 1x plus 4. So this tells us that the slope is negative 1 and the y-intercept is 4. So you could start your plot of your table at 0 giving you 4, and then since your slope is going down by 1 would give you 3, and 2 would give you 2, and so on, going down by 1. All right, next problem. Equation x minus y equals 4. Now, in order to solve this, to get the y alone, the first step would be to subtract the x from both sides. So we have negative y equals negative x plus 4. Now, when you're putting things in y equals mx plus b form, this y should always be positive. So instead of keeping that in negative y, we're going to multiply everything by negative 1 or divide by negative 1. It means the same exact thing. And this becomes y equals positive x plus negative 4, and that's the same thing as y equals x minus 4. So this is the y-intercept form. From there, you can make a table and graph it. This tells you that you start at negative 4, and that as you go up by 1 in the x, you go up by 1 in the y. So negative 3 is 1's answer, and 2's would be negative 2. All right, problem, try 2x plus y equals 9. You can go ahead and hit pause, or you can just keep on cruising. This one's pretty smooth because all you need to do is subtract the 2x. So you have y equals negative 2x plus 9. Done. All right, try this one. X plus 2y equals 9. You can hit pause, or you can just keep on cruising. All right, in this one, you would subtract x from both sides. So you have 2y equals negative x plus 9. And then in order to get the y alone, we need to divide every single thing by 2. So your final answer would be y equals negative 1/2 x plus 4.5. So we know that's a negative 1/2 x because this is a negative 1 in front of the x. If you put 0.5x plus negative 4.5, that's also acceptable. Sometimes it's just easier to keep things in fraction form. Negative 12. All right, the first step you should have done would be to subtract the 8x from both sides. So now you have 4y equals negative 8x plus negative 12. You could have a minus 12, and that's fine too. And then you need to get the y alone, so divide everything by 4, every single thing. You could make this one big divide by 4. You could also write it individually, divide by 4, divide by 4. That means the same exact thing. So y equals negative 8 divided by 4 is negative 2, and negative 12 divided by 4 is negative 3. You could also write this as negative 2x minus 3. Those all mean the same thing. Let's say you have y equals 5 minus 3x. That is technically in y-intercept form. You could rewrite that as negative 3x plus 5, and that's totally fine. Now, what if the question asked you to put this into standard form? So again, standard form is where you have the x and the y on the same side of the equation. So to get this back to standard form, all you need to do is bring this 3x over by addition. So 3x plus y equals 5. Now, the only good thing about standard form is it's easy to get the x and y intercept from this form. So we'll talk about that later in the video, but this one is probably easier for you to graph and generate a table. All right, next problem. Let's put this in standard form. So the first step would be to subtract the 3/4 x from both sides of the equation. We're keeping the balance, just like the teeter-totter, the coins and pouches. So negative 3/4 x plus y equals 1/4. Now that's great, but the proper standard form has x as no fraction. It also has y as no fraction, but it also has x as positive. So in order to get this x to be positive and no fraction, we're going to need to get rid of the negative first of all. So let's actually just do this in 2 steps. So we can write this as 3/4 x minus y equals negative 1/4. You can get that by multiplying everything by negative 1 or dividing everything by negative 1. And then to get rid of that divide by 4, we can multiply the whole entire equation by 4. So 3/4 times 4 is 3x. 4 times negative y is negative 4y. And 4 times negative 1/4 is negative 1. So this initial equation is what would have been the standard form to get this equation in y-intercept form. Those equations are the same table, the same graph, the same everything, 2 different forms. This will be easier for you to graph a line and generate a table. This is probably easier to find the x and y-intercept. Here's our next problem. Now, this problem, it's not in either form, so let's put it in both. The easiest form to put it in initially is probably going to be standard form. So in order to do that, we would subtract the 2y from both sides. So x minus 2y equals negative 3. There is the beautiful standard form. The x is positive, the x is not a fraction, the y is not a fraction, done. Now to put that in y-intercept form, you're going to need to solve for y. So subtract x. So negative 2y equals negative x minus 3. And then divide everything by negative 2 to get the y alone. So y equals x over 2. That's the same thing as 1/2 x. You could write that either way. And then negative 3 over negative 2 is positive 3/2, which is the same thing as 1/2. So this is the same as this. Either one's great. Now let's think about the different reasons you would want these different forms in terms of a story. So let's say Joe is selling popcorn for $5 a bucket and hot dogs for $4.75 each. After 1 hour, Joe makes $72.50. After 1 hour, Joe makes $72.50. So would this be easier to write in standard form or y-intercept form? Hopefully you think standard form. 5 per bucket plus $4.75 per hot dog is equal to $72.50. What about a different story? Anne is in charge of selling roses for $3.75 each. And she estimates the expenses are $25. Go ahead and write an equation for profit. So you've learned this year that profit is equal to income minus expenses. So the income is $3.75 per rose. And then the expense is $25. So that situation would be easier to write in y-intercept form. Have $10 per adult membership. And $5 per student membership. And the total income is going to be $400, and the total memberships are 50. All right, so this situation can be written as an equation, but there's two different equal signs. One is the equal to 400, and the other equal sign is the equal to 50. So how would you write an equation with the equal to 400 part, knowing that there's $10 per adult ticket and $5 per student ticket? Think about that. So hopefully you wrote 10 per adult plus 5 per student is equal to 400. Now, the other equation is about numbers, a total of 50 memberships. So that one, you don't need the 10 and the 5, you're just writing A plus S equals 50. So in order to graph both of these to find a solution, to find an intersection point, you could put them in y equals mx plus b and graph them using y-intercept and slope. You could generate tables. There's a ton of different things you can do. So let's look at this. This one, it might be easier to, instead of putting it in y equals mx plus b, to just think about what two numbers add to give you 50. It's also interesting to think about which one of these should be the x-axis and which should be on the y-axis. There's really not an independent and a dependent variable, so it doesn't matter. Since we've been doing x plus y for standard form, let's go with a being x and the s being the y. If you did this the opposite way, that's totally fine. So I'm going to label this graph right now that this is adult and this is student. Okay, and we can even title the graph so we don't forget. We'll put membership. Student should be on this side, backwards. So if adult is 0, then the student would have to be 50 because 0 plus 50 equals 50. Now, this point over 0 up 50 is the y-intercept. Whenever you plug 0 in for the x and solve for y, that's the y-intercept. It's where it's going to cross the y-axis. We can also get the x-intercept. Those are two probably pretty important points. So if you plugged 0 in for students, what plus 0 is equal to 50? That would have to be 50. So 0, 50, and 50, 0 are the two end points for this graph. Now, it's probably not going to be really helpful to go up by ones. That's a lot of points in the middle. So maybe let's just fill in going up by tens. You could go up by tons of different numbers. I'm going to just move this down a little bit. $10 was plugged in for adults. Students would have to be 40. If 20 was plugged in for adults, students would have to be 50. If 30 was plugged in for adults, students would have to be 20. If 40 was plugged in for adults, students would have to be 10, and then 50 giving you 0. Now, you could have solved this for s, like s would be negative a plus 50, but you probably don't really want to go up by ones because these two endpoints are pretty important. All right, let's see what these numbers are. So the one method to solve is to get the two intercepts. So you could plug 0 in for a and solve for s. So I'm going to write the work right here and then erase it. So 10 times 0 plus 5s equals 400. So that's 0 plus 5s equals 400. So when does 5s equal 400? So you would divide by 5. So s would equal, 5 doesn't go into 4, so 5 goes into 48 times. So 400 divided by 5 is 80. So 0 gives 80. So that would be the lowest point because the negatives don't really make sense. The lowest point on the x-axis. Now the highest point on the x-axis will be when this one is 0. So 10a plus 5 times 0 equals 400. So 10a plus 0 equals 400. So 10a is equal to 400. So a is equal to 40. So 40 is the biggest point, and then we want a few in between. Now, instead, let's say that you solved this for y. So this is one option, and if you're going to continue this, you'd probably want to find the points 10, 20, and 30. It might be nice because that's what this one is. You could also solve for y by doing 5s equals negative 10a plus 400, and then dividing everything by 5. So negative 10 divided by 5 is negative 2a, and then 400 divided by 100 divided by 5 is 80. So that's where you get plugging 0 in, 80, and then as you go up by 1, you're going down by 2. So you can plug 10 in for this a right here, but you could also plug 10 in for this a right here. And you can solve either one. I personally think it's easier to solve this. It doesn't matter which one you do. There's tons of right ways to do math. So negative 2 times 10 is negative 20, and negative 20 plus 80 is 60. Negative 2 times 20, I'm going to plug this one in now, is negative 40, and negative 40 plus 80 is 40. And you can probably see a pattern that you're going down by 20. So 30 you're expecting maybe to be 20. So negative 2 times 30 is negative 60, and negative 60 plus 80 is 20. Okay, let's graph this stuff. Can you see already where they cross, where they intercept, where they're the same answer? Hopefully you're noticing that right here, 30, 20 is the point that they have in common. So what would be a good number to count by on the x-axis if we're going up to 50 over here and 40 over here? So maybe by 5s. And then what would be a good number to count by on the y-axis? And we need to get up to 80, so my graph is smaller. Since mine isn't quite big enough, I'm going to count by 10s, but you're welcome to count by whatever your graph will allow you to. Okay, so for this equation, over 0 up 80, over 10 up 60, over 20 up 40, over 30 up 20, and then over 40 up 0. Do you think it would make sense to connect the dots? Do you think the numbers in between here work? Probably. The decimals don't work, but the whole numbers work. You can't have half of a person. So I'm going to go ahead and connect these dots. And then over here, over 0, this is how far over, this is how far up 50. Over 10, up 40. Over 20, up 30. Over 40, 30, up 20. This is our nice important crossing point. And over 40, up 10. So again, we're going to connect these dots. And since we're noticing you go over 2, down 1, over 2, down 1, the next point would be right here, which is also right there. Now, remember slope is rise over run, but this really is 10 as the rise and 10 as the run. So this slope is -1, which you would know if you solved for s, because s is -a divided by 50. Okay, so the place where they would be to have 400 adults and 50 members is 30 adult tickets and 20 student tickets. That's the point that makes sense for making this much money selling 50 memberships. Plus y equals 4 and x minus y equals -2. So the question is, where do these cross? Now, again, you can go right from here and generate tables and graph those. You could also put them in y equals mx plus b and graph them that way. For this one, I think I'm just going to put in y equals mx plus b. You totally do not need to do that. So subtract the x for this. And then over here, you would subtract x. -y is equal to -x minus 2. And then you would divide by that -1. So positive y is positive x and positive 2. All right, so I'm going to generate a table for both. In this one, 0 gives 4 because that's your y-intercept. And then since your slope is -1, that just means you're going down by 1 every time. So 1 would give you 3, 2 would give you 2, 3 would give you 1, and 4 would give you 0. -4 plus 4 is 0. Let's plot that. So might as well just count by ones. You could even count by a half and spread it out. So 1, 2, 3, 4, 5. I actually think I'm going to count by half. So 1, 2, 3, 4, 5. And then here, 0 will give 2, 1 will give 3, 2 will give 4, 3 will give 5, and 4 will give 6. So if we plot these both, then we need to go up to 6 on the y-axis. So I'm just going to count by ones because I don't have room. So that's my y. Since this isn't really a story, I'm not going to put a title. So this one is over 0 up 4, over 1 up 3, over 2 up 2, over 3 up 1, and over 4 up 0. We should connect the dots because we don't know what the story is, so this line does continue forever. And go ahead and draw an arrow in both directions because it really continues forever. And then over here, 0 gives 2, so now we're plotting this one. And 1 gives 3, and this is an exciting point because that's where they cross. So this is the solution. 1 gives 3. This point works for this equation, and it also works for that equation. It works for both equations. That's a solution point where they cross. 2 gives 4, 3 gives 5, and 4 gives 6. Again, go ahead and connect these dots. and draw an arrow both ways. So we can solve this system of equations by graphing, and the solution is where they cross, and that solution tells you that that ordered pair point works for both of these equations. That's the only point that works for both of these equations. So these two lines have one solution. They have a different slope. This is a positive slope. This is a negative slope, negative, positive. And they have a different y-intercept right here. Okay, second problem. Next problem is 2x plus y equals -1 and x plus 2y equals 7. So we have a system of linear equation, two lines, and we're going to try to figure out where they cross by graphing. So right here, you could find the x and y intercept. You could put it in y equals mx plus b and make a table. I think that's what I'm going to do. Tons of right ways. You'll end up with the same table no matter which way that you go about solving this. Okay, so -2x plus -1, we just subtracted the 2x. And then to generate a table with x and y, if you plug 0 in, you get -1. If you plug 1 in, -2 plus -1 is -3. This is telling you that each time you go up by 1 in the x, you're going down by 2 in the y. So 2 is going to give you -5, 3 is going to give you -7, 4 is going to give you -9. Over here, I am also going to just solve for y. This one's going to be a little more work. -2y is equal to -x plus 7. And you're going to need to divide by -2 every single thing. So y equals -1 over -2 is just 1/2 x. And then 7 over -2 is -3.5. Okay, so to make a table of this, 0 would give -3.5. And then each time you're going up by a half. So 1 would give -3. And 2 would give -2.5, 3 would give -2, and we already have the solution point, so we don't even need to go any farther. And if you know something's linear, you don't need a ton of points. So this graph is all negative in the y. So I'm just going to make the x-axis right here of 0, 0. So 0, 1, 2, 3, 4. And then on your graph, we really need the negatives. So -1, -2, -3, and so on. All right, so this first equation, 0 is -1. 1 is -3. 2 is -5. 3 is -7. And 4 is -9. Connect the dots. Oh boy. Second equation. 0 is -3.5. 1 is -3. So this is a positive slope. It's going up. This is our exciting point. That's where they cross, and that's where they're the same. So 1, -3 is the solution to this system of equations. 2 gives -2.5. 3 gives -2. You could even keep going. 4 would give -1.5. 5 would give -1. And then you can connect those dots. So these two linear equations have one solution. Next up. Our next system is going to be -2x plus y equals 3 and -4x plus 2y equals 6. Now again, you can find the x-intercept and the y-intercept and go that route. You could put this in y equals mx plus b and go that route. Finding the x and y-intercepts is going to give you some fractions. So I'm going to go ahead and add 2x. There's not a way to do it. They're both perfectly acceptable. So y equals 2x plus 3. Over here, let's add 4x. So 2y equals 4x plus 6. And then when you divide everything by 2, you get y equals 2x plus 3. Well, that's interesting. They're the same exact equation. So let's go ahead and graph this equation, but what does it mean in terms of what the solution is for these? So the table would be 0 giving you 3, because 0 in for x gives you 3. If you plug a 1 in for x, 2 times 1 is 2, plus 3 is 5. If you plug a 2 in for x, 2 times 2 is 4, plus 3 is 7. You can also see that this is going up by 2 every time. So 3 gives you 9, and so on. So to plot that, this is our x-axis. 1, 2, 3, 4. This is our y-axis right here. 1, 2, 3, 4. So over 0 up 3, over 1 up 5, over 2 up 7, over 3 up 9. Go ahead and connect those dots and draw arrows. And this is that graph, and this is also that graph. So every point that works for this equation will also work for this equation. So the answer to this is all solutions. So again, every point that works for this equation will also work for this equation, and that's why every point on the line is a solution for both, all solutions. The final linear system is going to be negative 2x plus y equals 3 and negative 4x plus 2y equals 10. So again, in order to graph these, you could solve the x and y intercept, or you could put this in y equals mx plus b form and solve that way. So y equals positive 2x, because you would add 2x to both sides, plus 3. So we can generate a table for that. 0 gives 3, 1 gives 5, 2 gives 7, 3 gives 9. Same as what we just did. Okay, the next equation over here is add 4x. So 2y is equal to 4x plus 10. And then to get the y alone, you would divide everything by 2. So y equals 2x plus 5. So this, for x, 0 is going to give you 5 as your answer for y. If you plug a 1 in for x, 2 times 1 is 2, 2 plus 5 is 7. 2 will give you 9, 3 will give you 11. You could just keep adding 2 because that's the slope. Or you could literally plug each x in and solve for y. So let's plot these. On our x-axis, we can go up by ones. You could even spread this out more and go up by halves, or you could extend your tables longer. And on the y-axis, we need, well, this one gets up to 11, so I'm just going to count by ones. So we're going to plot these points. This is x, this is y, this is over, this is up. So over 0, up 3. This is also known as rise, eek. This is also known as the run, and this as the rise. So over 1, up 5, over 2, up 7, and over 3, up 9. Go ahead and connect the dots. There's no story problem saying that we can't. Drawing a straight line. And we're looking for where these cross. We're looking for the solution to the system. So right here, 0 gives 5, 1 gives 7, 2 gives 9, 3 gives 11. What's going on here? If you can graph a lovely straight line, what's going on is these are never going to cross. They have the exact same slope of 2, and they have a different y-intercept, because if they had the same slope and the same y-intercept, they'd be the same line, so it'd be all solutions. But this has a same slope with a different y-intercept. So these are two parallel lines. They're never going to cross. So this has no solution. You're able to graph two systems of linear equations and know if you have one solution and what it is, or all solutions or no solutions. And hopefully you can go from standard form to y-intercept form to manipulate these equations. In Google Classroom, the document posted, it does have a Google form that it would be great. It's a little quiz if you could try that right now, or you can go to the document and there's worksheets or Khan Academy to practice. But if you could do the Google form, the little quiz, then we can give you some feedback. So hopefully you learned something today, and see you again soon.